Now that we know how to deal with the angle-angle postulate, we're going to look at the other two ways of proving triangles similar, and those would be the side-side-side similarity, and then the other one is side-angle-side. So use side-side-side if they give you 3 side lengths in both triangles, and then if they give you 2 side lengths, then it's probably likely that you're dealing with an angle as well for side-angle-side. So I've got a couple examples here. Looking at letter A, notice how they give you 3 side lengths in one triangle to 3 side lengths in another triangle. Most likely, we're going to try and use the side-side-side similarity theorem. You don't necessarily have to in letter A. You could actually use side-angle-side if you wanted to, if you picked the correct sides. But since they give me all 3 sides, I'm going to try and use the side-side-side theorem. So now we need to try and match up all of our sides with one triangle to another triangle. And I don't care which triangle you put on top. So I'm going to put the smaller triangle on top of the other triangle. So that means 6 has to go with 15. I'm going to go 6 over 15. 8 is the biggest side length between 5 and 6. So the biggest side length down here would be 20. So that means 8 has to go with 20. Leaving me with 5, the smallest side length, going with the smallest side length down here of 12.5. You need to reduce these, and if you reduce these fractions, each one of them is going to come out to 2/5. Which means that they are similar by side-side-side. Then we also need to come up with a similarity statement. So we're going to say triangle RPQ is similar to triangle. R has to go with R. And since I went with P, then I need to go to S, T. And the reasoning is by side-side-side. Looking at letter B, there are 2 triangles in here, although you need to be a little careful. We know that angle A is going to be congruent to angle A by the reflexive property. Then, for your side lengths, 8 is going to go with 12. And I got 12 by adding up this entire side length. AC represents the longest, or one of my side lengths of my bigger triangle. And that needs to equal 10 over, add up 10 and 5, that would get you 15. If we reduce these come out to 2/3. Since I showed that 2 sides reduce to the same scale factor along with an angle measure that's between the 2 sides, we know our 2 triangles are similar. So we're going to say triangle AEF is similar to triangle ACB by side-angle-side.